Hello and welcome to What's New in Argo CD 2.12. This release has over 30 new features, 70 bug fixes, and 60 documentation updates. In this video, I'll present the top 6 features, in my opinion, that you need to know about from this release. This video is presented to you by Acuity, the company founded by the creators of the Argo project. I'm Nicholas Murray. I'll be walking you through these features today. I'm always happy to connect on LinkedIn and chat about anything cloud native related. Check out the links in the description down below. As always, I've created a repository that includes a breakdown of these features and a deb container, which means you can go spin up a free environment in GitHub Codespaces to test out this new version without touching any of the infrastructure or your own workstation. It'll spin up Argo CD for you, and you'll have an environment ready for you to go and play around with this new release. Check out the link in the description down below. The first feature I want to talk about today is the addition of the Sources tab in the application details pane. So, in the original implementation of multiple sources for applications, the UI only displayed the first source of an application and the parameters couldn't be edited. Now, as of Argo CD 2.12, support has been added to show all the sources of a multi-source application under the new Sources tab, which replaces the Parameters tab. Let's jump into what this looks like. So in this example here, I have a multi-source application. If we look at the raw manifest for this application, we can see that it contains a top-level source that's pulling a chart from a Helm chart repository, and a second source that's used to supply a values file to the Helm chart that I'm pulling in the first source. If you want a more in-depth example of this functionality, the ability to use a multi-source application to pull values files from a separate repository that you're pulling the chart from, check out the link in the description down below for my demo on that. So what's new in 2.12 is this Sources tab right here. So if we go into the Sources tab, it now breaks down the sources in this application rather than only displaying the first one. So I can see from a high level here the repo URL of the source and the revision of that source that it's targeting. So I can see my Helm chart repository, and I can also see my GitHub repository. So if we compare this to what it looks like in a single source application, you can see that a single source application has the repo URL, the target revision, and the path for the source in the summary of the application details. And then there's a separate parameters tab that describes the parameters for the source of that application. In this case, I have a customized application, which means it'll show me the images for that application that I could override, similar to the native customized functionality. Now with Argo CD 2.12, if I look at the summary page for my application, you can see that because this is a multi-source application, the repo URLs and the target revision are no longer contained within the summary, but have now moved over to the Sources tab. From this Sources tab, I can see the repo URL and the target revision of my sources at a high level. And then if I click into them, I can see the repo URL, the chart, the parameters that I'm supplying to my multi-source application. This improvement is part of an extensive proposal to add UI support for multiple sources and applications. If you'd like to check out the full details, I'll include a link in the repository that contains the demos for this video. A key feature of Argo CD is the ability to roll back an application to a previous revision. Despite the fact that doing rollbacks from the UI is technically an GitOps anti-pattern, it's still incredibly handy for fast rollbacks to mitigate a problem in the moment until you can implement a proper roll forward, meaning that you make a change in Git to create a newer version that Argo CD then syncs into the cluster. When the initial support for multiple sources for applications was added in Argo CD 2.6, there were several places in the CLI and UI where the support hadn't been added, including rollbacks. So that is the next feature that I want to cover for Argo CD 2.12 is the addition of multi-source application rollbacks from both the UI and the CLI. So as of Argo CD 2.12, you can now see the information about the revision for both sources for each item in the history and rollback page, and you can also initiate a rollback for an application to the revision of both sources from that point in time. Let's take a look at what that looks like. So from my multi-source application here, if I click on history and rollback, I can see the current iteration of my application with the revision for my first source along with the parameters for it, and also the revision for my second source and any related parameters. Then if I go down to the previous iteration of my application and I click to see the source details, I can see what it looked like at that point in time. I can see how long it was active for, all the standard features of a single source application. Then if I want to initiate a rollback, I can go over to here on this entry in the history. If I click this, I can then initiate a rollback for my application. Now, of course, my application has autosync enabled, which a part of the rollback functionality is to disable autosync. And that's essentially what makes this a GitOps anti-pattern, is we're now saying in Argo CD what the revision should be, rather than allowing the GitOps repository to be my source of truth. So I can initiate a rollback, it'll do the sync, it's going to roll over to my previous replica set because that's what changed in my application. Autosync is now disabled for it. And so this gives me time to go and fix or mitigate whatever problem that I needed to roll back, to then eventually make the roll forward in Git and reinitiate that GitOps sync. So allowing Argo CD to then trust Git as the source of truth again, and maybe even enable autosync for my application again. So for everybody that has been waiting over a year for this feature to get implemented, it's finally here, and you can start rolling back your multi-source applications just like any normal single source application. In a self-service multi-tenant environment, teams and separate app projects may want to use the same repositories. So I've got Team A and Team B, and they both rely on repository A. They may have their separate app projects. Team A has app project A and Team B has app project B, but they're both relying on repository A. So using RBAC in app projects, it's easy to prevent teams from having access to each other's repository credentials, at least in theory. However, prior to Argo CD 2.12, when there was multiple repository credentials referencing the same repo URL, Argo CD would use the first credential found matching the URL given. So if we had two separate repository credentials, both referencing the same repo URL, but they were referencing different credentials, it was possible for Team A to end up taking advantage of Team B's repo credentials to access and sync their applications, which could potentially lead to escalated privileges, which could end up giving Team B access to manifests that they weren't intended. So the workaround at the time was to have a shared credential between the teams and rely on an Argo CD admin to add it for them, rather than teams being able to manage their own repo credentials within their app projects. This restricted your ability to have fine-grained access control to your repositories. As of Argo CD 2.12, the repository credential lookup will now attempt to find the first repository secret that matches the project defined in that repository secret and the repo URL of the application that's trying to sync. Then, if there are no repo credentials matching the requested project, it will then fall back to the default credential, the first one that is not scoped to a particular project that matches repository URL that's requested. So notably, what this means is that a repository credential secret, so repository credentials are contained within a standard Kubernetes secret, but they follow a specific format and use labels for detection. That repository secret now accepts a project field to facilitate this functionality. So with different sets of credentials, there's a potential for an app project to fetch different manifests. So to mitigate the unintended access and conflicts between these repositories fetched by these credentials, the repo server will now check out a separate copy of the repository per app project. So this means you'll have clear separation between the manifests that are checked out using credential A and credential B for the separate app projects. Ultimately, this enhancement will enable self-service capabilities for dev teams while preventing inadvertently exposing repository credentials belonging to other app projects. So if you look at the first repository credential that I have here, you can see that it's not scoped to any particular app project. The second repository credential I have here is scoped to the default app project. So prior to Argo CD 2.12, the repo server would take advantage of whichever one of these credentials appeared first or was returned first. So that means an application in the default project, instead of using the credential that's specifically scoped for it, it could end up using the default credential that is available across all the app projects. So the update to Argo CD 2.12 is Argo CD will now first check for a repository credential matching the URL and the given app project. So if an application in the default project is attempting to sync and it's using this repo URL, Argo CD is now guaranteed to return this repository credential first, and then any application outside of the default app project, because there's no other repository credential scoped for those projects, it will fall back to using the one that's not scoped to any particular project. We can take a look at what this looks like in terms of Kubernetes secrets. So the main difference here is that the repository secret now accepts this project key, which will scope it down to a particular project. And then this repository credential would get used for any project that isn't the default one, any project that doesn't have a repository credential specifically scoped for it. Labels on Kubernetes resources are often used to differentiate between teams, environments, cost centers, and services. These labels are then used for routing of messages relating to those resources, alerts to the appropriate channels or team. For Argo CD, applications produce Kubernetes events when performing various operations like initiating a sync or changes in health status. Prior to 2.12, the events produced from an application were tied to the resource, but it didn't include any of the metadata, making it difficult to filter or route the events to the appropriate destination without creating fragile and complex scripts to parse the team and environment information from the application name, if that was available at all. So the next feature I want to cover is the addition of application labels on Kubernetes events. So as of Argo CD 2.12, labels on applications or their app project defined in the optional resource.include event label keys, which is a comma separated list of the meta.label keys in the Argo CD config map, can be added by the controller to Kubernetes events generated for applications. The labels then establish an easy link between the event and the application, allowing for filtering and routing of those events. So let's see what this looks like in practice. So to start off here, I have my Argo CD config map. In the config map, I've configured the include event label keys to look for the team and env labels on my applications. Any of these labels that exist on an application will now be included on events produced by that application. I've also taken advantage of the exclude event label keys parameter as well to say anything that includes environment or BU should be excluded from being added to Kubernetes events. And then on my application here, I've included the team Kubernetes admins and the env dev label. Now that I've configured this in the Argo CD config map, these labels should be included on any Kubernetes events that are produced for this application. So if I open up my terminal here and I run kubectl get events, I can filter down the events to the label that's included on my application by using -l and then equals env dev. So if I run this command, I can see all the Kubernetes events that are produced by Argo CD applications that contain the env dev label. Now this feature will include any of the matching labels from both the application and the parent app project of that application. So in the event that there's a conflict between the two, the application label values are always prioritized. This feature will be incredibly useful for anybody that's exporting the events from their Kubernetes cluster to a log aggregation platform like Datadog or to an AWS ELK stack. And then from there, you'd be able to filter those events in your logging platform down to the specific applications or all the applications under a specific team or under a specific environment or business unit and allow you to properly filter through them. This is very similar to the functionality to be able to attach labels from applications to the Prometheus metrics outputted by applications, but now it's for Kubernetes events. So this next feature is a fun one. So if you're not familiar, to update some common Kubernetes resources, such as a job or a cron job or pods that are managed directly, and you need to be able to forcibly replace those resources if you want to recreate them with the same name, because the name on these resources or other fields on them ends up being immutable, which means that you have to either create a new unique job with a different name, commonly accomplished with the generate name function, or you have to delete and then recreate those resources, which is what the kubectl replace force command will do for you. Take this job, for example. I already have this job. It exists in my cluster. It's ran. It completed successfully. To Argo CD, it is synced and healthy. Say I want to adjust the amount of time that this job sleeps for from 6 seconds to 8 seconds. That's the only change I want to make to it. I'm using a static name for the metadata of the job. So let's try to sync that into the cluster with Argo CD. If I save the changes to this resource, you'll see that it is unable to patch the resource because it's immutable. The job has already run. It already exists in the cluster. There's already one that exists with that name. And the mechanism that Argo CD uses here is kubectl apply, which isn't compatible with a job that contains a static name. So Argo CD already has the ability to use the force flag during a sync operation. So if I try to sync this, I can select the force option here. Now, using force on a sync is a destructive action. It's going to attempt to delete and recreate the resources, which can end up having unintended downtime for your services. And this runs force across the entire sync operation. So it could attempt to forcibly replace unintended resources during that sync operation, ones that you didn't expect to get deleted and recreated as a result of using the force option. Now, Argo CD has a mechanism for specifying sync options on a per resource basis, and that's using the Argo CD sync options annotation on that said resource. So prior to 2.12, the sync options annotation supported the replace option, but it did not accept the force option, which meant you were able to take advantage of running kubectl replace on a per resource basis, but you weren't able to force that replacement for resources like Kubernetes jobs or cron jobs. So that's exactly what 2.12 introduces, is the force flag to the per resource sync options. So this allows you to fully replicate the kubectl replace force command on a per resource basis. So this combination serves as a way to ensure that a job is run every time an application is synced if resource hooks aren't appropriate for your use case, and it helps address any resources that end up being immutable after they're initially replaced. An interesting example is the Google Cloud IAM policy member resource, which is immutable after it's created. But with this, you can now say on sync, if there's a change to that resource, simply delete it and recreate it during the sync of that application. Okay, last but not least here is an exciting update to the sharding algorithms of the application controller. So if you don't have context for why this is important, let me back up for a second and give some context. The application controller for Argo CD is responsible for managing applications and their resulting resources across all the clusters managed by an instance. So to scale the application controller, it must be sharded, meaning that there are multiple instances of the controller, and each one is responsible for a subset of clusters and their applications. There are a number of challenges with application controller sharding, primarily in regard to the distribution of load between those shards and rebalancing the load between those shards during changes to clusters. These challenges often lead to some of the shards handling most of the work, while others sit idle with very little load, kind of similar to a bin packing problem. One of the shards may end up taking responsibility for 2 highly active clusters with many resources, while other shards end up being responsible for 1 Kubernetes cluster that only handles few application resources. Distribution of work between the application controller shards is determined by the sharding algorithm. The existing algorithms include the legacy method and the round robin algorithm have limitations when maintaining an optimal distribution of load and minimizing the unnecessary cluster to shard assignment changes. So the round robin one simply distributes clusters among the shards in a round robin basis. The legacy method used a hash of the cluster UID to distribute them among the shards. Both of them were not optimal for load distribution and didn't update very well when there was changes to the assignments between shards. In Argo CD 2.12, a consistent hashing with bounded loads sharding algorithm has been added with the aim to improve the efficiency and effectiveness of the application controller shard, particularly when it comes to the number of shards, clusters, or applications. So what the new algorithm will provide is a reduced cluster to shard assignment changes. That's the bounded loads part of the algorithm. So this minimizes the redistribution of cluster to shard assignments, especially when altering the number of shards, resulting in more stable and efficient operation. Dynamic load rebalancing. So the algorithm should dynamically adjust the weights based on the load. The algorithm should dynamically adjust the weights based on the load, ensuring that the shard with the fewest applications managed receives a higher weight during shard assignment. A shard managing very few applications becomes a higher weighted candidate during shard assignment, meaning it's more likely to receive the new cluster or the new assignment to that shard. So this improves load balancing between the shards. And then ultimately, this optimizes resource utilization. So the algorithm should contribute to better resource utilization by maintaining a balanced distribution of applications across the shard, which prevents the need to provide excessive resource allocation to shards on the off chance that some of them end up maintaining significantly more applications than others, solving the bin packing problem. Now, the new feature is considered alpha, and so the project is actively seeking feedback from end users. This has been tested extensively by the Canoe project, and you can check out a link to their blog post in the pull request for this feature, but they are seeking feedback from other organizations to ensure that it's working well for your needs. So to enable the use of the consistent hashing with bounded loads sharding algorithm, you can adjust it in the Argo CD command params config map. And so this effectively adjusts the sharding algorithm command flag passed to the application controller. So in the controller.sharding.algorithm value key in the config map, assign it to consistent hashing, apply the change, roll out a new version of the application controller, and then you can start taking advantage of this new sharding algorithm. All right, thank you for watching. Those are the features that I decided to cover from Argo CD 2.12, but I'm interested in hearing if I missed any that you think deserve a moment in the spotlight. I think this release is another great example of the progress that the Argo project is making on giving multi-source applications first-class support and the improvements to scaling Argo CD through the research and advancements in the sharding algorithms over the last few releases. If you're interested in operating Argo CD at scale, reach out to Acuity to learn more about what they have to offer in reducing the operational burden of continuous delivery and continuous promotion in your organization. Once again, I've been Nicholas Murray. I'm always happy to connect on LinkedIn. Check out the Acuity YouTube channel for more Argo project related content, and also their free course in the description down below for getting started with Argo CD. Thanks for watching, and I'll see you next time.